Any anion that we have can potentially be a base, because if we think about the anion, it is the conjugate base of an acid. The stronger that acid is, the weaker the conjugate base. So if we think about this, the strong acid is going to want to break up nearly 100%. And if we have the anion from that, it is not going to want to associate with the H+, and so nearly 0% of that ion is going to want to form back into a strong acid. So if we have an anion like Cl-, because it's conjugate base of HCl, which is a strong acid, it is going to be pH neutral. An anion that is the conjugate base of a weak acid, however, is going to be basic when we put it in solution, because some of that anion is going to want to associate with hydrogen to form the weak acid. Let's look at a couple of examples. If we look at nitrate, NO3-, its conjugate acid is HNO3, nitric acid. This is a strong acid, which means that its anion, the conjugate base, is neutral. So if we have nitrate in solution, it is not going to contribute towards the pH of the solution. It's going to be neutral. However, if we have nitrite, NO2, its conjugate acid would be nitrous acid. So HNO2 is a weak acid. That means that NO2- is going to be basic, because it has a weak acid as its conjugate acid. That means the anion will be basic.